in this session, we would like to show and on practice how easy it is to use native image as a builder and how easy it is to configure native image, and you will always hit some error you might hit, but we will show you that this is all doable and fixable, and we have links for that. So Thomas,
right, cool.
Let's start.
The first program here that we have to showcase some native image features is it's a very small Java program here, and it is using the SLF4J library, and it has configured as another dependency here, as another jar dependency, that we want to use log4j as our SLF4J logging library. And this has been often requested that we need to support these logging libraries. And here we have a small program that is using these logging libraries. We can go to the console. I have here GraalVM. I have here the community edition installed. I'm using SDKman, so I can list all Java that I have here locally. I can change my Java version by saying SDK install Java, and we're gonna use today the GraalVM Enterprise Edition. Both actually works the same way, and you also can use the Enterprise Edition during development or testing or anything like that. So now I can do -version, and SDK use Java, right? What is the command again, Oleg? Yes, now I have it.
Right, yes. And when you install a local thing, you need to add the path, right, as well. So if you want to SDK install Java GraalVM Enterprise Edition, like you add the path to that, but you had it before, so
right,
that worked, right?
Cool.
But
yes, so I just did SDK use Java, and then I did my GraalVM Enterprise Edition, and now I'm here on the Enterprise Edition.
By the way, the development team behind native image say that it's better to use Java 11 distribution for native image. It's more effective. It should be.
Yeah, exactly. We see here we use GraalVM 21, and it's based on OpenJDK 11.0.10, which means we have here Java 11. Okay, that's cool. And I can now run ambient package, which is creating the jar file for my application, and I can just run the jar file with the appropriate command. And I have here maybe a plugin that creates me a jar file with all the dependencies included, so I can just run this and it runs my app. Okay, so now I want to create a native image out of this app, and yeah, for this I just do native image -jar, right? And then I put the jar file in again, and I run that. And we are now expecting this to fail. The reason we're expecting this to fail is that it is using some reflection and dynamic configuration from that logging library. Oh yeah, and here we see it. So we have here now various warnings because the logging library uses class for name, class new instance, class get method, etc. The build process still goes on, and it will actually still create an image, but it will not create a real native image that is compiled fully to native code, but it is creating a native image that is still requiring a GraalVM or other JDK for execution. And that's kind of not what we want, right?
Yeah, but if you pass no -- no fallback option to the native image builder, that will ensure you either fail at the build time,
right?
If you provide necessary configuration, that you will build successfully, and it will be a complete native executable.
Right. Yes. Yeah. No fallback would suppress this, but here we actually do have now some image. But if you run that image in the background, it will still use JIT compilation, and it's kind of not what we want. So let's delete this file, and let's use now the native image tracing agent to get this reflection configuration automatically. So for this, we need to run again Java, and what's the command now for the native image?
Now you do dash agent lib, then column native dash image dash agent,
okay,
and then equal sign, and then you have to pass the option to tell where you would like to write the configuration files to. So the pass to the output directory, and the option will be config dash output dash dir equal sign, and then just the pass. And then you pass -jar and the jar result dependencies.
Right. Yes, so and the pass, I think we should select the pass to such that this config is then automatically included in the resources of the Java.
Right. The native image builder is taught to pick up everything that it finds under meta-inf/native image directory. So whatever configuration files you put there, it will pick up all under this location.
Right. So we do source main resources, right, meta-inf, and then native image, because this directory is what would automatically be picked up as the next generation, like the next configuration when we generate an image, and then we put the Java,
right, yeah. So the prerequisite is to pass the agent lib after the Java command and before the jar command.
Right. Okay, good. And then we do jar with dependencies jar. Okay, and that's it. Okay, cool. Now we can check out if it actually generated something by going to IntelliJ, to our program. And yes, here we see now the files generated in the resources directory meta-inf.nativeimage. And we see...
and the file names, as you can see, they are all like predefined as well. You should not change them. And since recent release, in the last major release, also serialization support was added to native image, and now the tracing agent can also trace classes involved into the serialization activity. So now you have also serialization option included. But
we have GNI, right? But our program doesn't use any GNI. We have proxies. Our program doesn't use any proxies. We have reflect. Okay, here something was generated. So we see now that somebody was reflectively accessing thread.getClassLoader, and somebody was reflectively instantiating log4j category, log4j logger, and log4j loader, right? I mean, yeah, this is what we expect, because the slf4j library would reflectively load the log4j instances. We have a resource config, which a resource file is accessed, and somebody is here apparently accessing this resource, which is the static logbinder.class. And we have, as you mentioned, since new, also the serialization config, but no serialization happening in this application. So this native image agent is also something you can use just to check what of these elements your application is using.
Right. Yes, it interfaces with the GVM to intercept all calls to proxy, all accesses to proxies, classes or methods, whatever reflective accesses you have in your application. So
right. So this is a very good way, also in general, just to test your application of like how.
Yes.
And the more configuration your application puts out here, the more difficult it is going to be to get native image to be efficient on the application. And and this is a very good way, initial step, to just run some workload on your application and check out what it says there. Right, and now this config should be automatically picked up. So we now need to, I think I need to run maven package again. So I run maven package such that the resource file is added to this jar. I think we can I think we can have this jar command. Jar. We can look it up if this is really in there. And we want jar list the components, jar -t. Maybe not. List the table of contents of the archive. All right, let's ask check overflow. List jar file contents. Viewing contents of a jar file. TF. I was missing the TF flags. The TF. Okay, now we can check out the contents of the jar file with jar TF, and jar TF gives us the contents. It's a lot of log4j contents here. We can grab on this, and let's maybe grab meta-inf. And now we see the meta-inf contents, and we see that this directory from the native image was added to the jar file as we were expecting. And now the jar file has the native image configuration included in the meta-inf directory, but it has also other things like the manifest file and so on.
Yeah, but that shouldn't be a stopover if you have some other configuration files in your project in some other location, like under resources, but as a folder, for example. Then there is an option also to include resources. So that -h column, then include resources, and then the path to your configuration file. And you also feed it to the native image builder at the build time, and it should pick up other configurations as well.
Okay, yeah, we can make it pick up others as well, but this will be the default location that picks it up.
Yeah.
Cool. So now we can again run native image, the native image command, exactly like we had it before with the jar file. And this time it should now no longer display the warnings. And it should, because of this configuration, now automatically create the image.
Yeah, but imagine if you have to rerun your application and it expects some user input, then this input won't be accessible at runtime. Yes, so you will have to rerun the agent again, and then you will have to tell the agent to merge the previous configuration files with the next round of the configuration files,
right.
And there is a separate option for that. So you can also try that.
Okay, yeah. Let's try that right after. It just created the image. So just show that the image does exist here. It's here 13 megabytes with the image with that log4j test, and we can run it, and it just runs it now with a very good startup, obviously, and it just runs. And yeah, you're right. In this application, we are lucky in the sense that the reflection is not dependent on user input. And so in order to get the complete reflection configuration, one would have to exercise the application in a way that all the reflection paths are actually hit. And
right. All the possible execution passes are actually kept.
Right. Yeah, and for this, let's just now modify our application to use a little bit of a manual reflection. And let's just make here like a public static void foo method where we like print out some string, and then we can here say main.class.get method foo, and then we invoke it with one parameter, which is null, which is because the static method we invoke it with null.
But
right.
But you would instead of calling foo, you would probably want arguments.
Right. I think that should be okay. Let's see. Yeah, we already have these exceptions here. I think this would still, this would invoke foo here. I think so. So let's do mvm package. Mvm package. And on the mvm package, we can now again run our application -jar target and our log4j test with dependencies, and it will execute here foo bar. So now, so the thing I think is that in these type of calls, native image analysis is actually clever enough to even recognize themselves that without any help, without any configuration help, native image will recognize this call as a reflective call and include the foo method in the image. So in order to trick native image into not knowing which foo to invoke here, we need to have the app a little bit different, where we are making a reflection call that is really not, you cannot statically determine what reflective method is called here, because the name of the reflective method would be given as an argument. And in this scenario now we have a new reflection call that would, so if I give foo here, it will say foo bar. If I give something else here, it will just give me a no such method exception. And now this reflective call is really dependent on user input. So it's now the user input scenario that we were talking about before. And in this scenario now, we would, when we create the image, we would not, the native image generator would not know that this method is actually reachable. And this will be because we don't want to include every method in the whole universe in our image, because we want to keep our images small. So that's why we then like say here, okay, we are not including this foo, and we would only include the foo if we would have here a reflection config. And now I think we can use this merge option that you were referring to before, right? So we again do Java and then -agent colon, and then it was, what was it?
You missed agent lib.
Agent lib.
Then colon, then native dash image dash agent.
Okay.
Equals signs, and then config dash merge dash dir, and then the same path to the directory.
Right, that would same directory, right? So it's again in the sources, and then it's main resources, right? Meta inf native image. Okay, and now we can give the -char target, look for JTest -char dependencies, and then we can so if you now see here foo again, now we executed the application with the reflective call to foo, and if you now go to our reflect config, so now we have a new entry on top, which is the entry to that config. And now with that I can do an npm package, and I can do again my native image command. So now it has an updated configuration where in the reflect config.json it has now a new method that is reflectively accessible, which is the method foo with no parameters, and it's accessible. This method is a method of the class main. Some of this you can also, like this could also be manually generated, or some frameworks like Spring, Quarkus, Micronaut are generating these configs automatically. But with our tracing agent, we can also create it just based on the user input, or at least get like a first view of like how much reflection and other runtime specific things a native image would use.
By the way, there is one handful option. If you would like to see what exactly native image picked up, what configuration, you can also pass this option -- native image info at the build time.
Here,
for example, if -- native image info.
Info, right? Okay, cool.
So it will give you information about your environment, the GraalVM version, the native toolchain information, and also the configuration used.
All right, cool. Yes, and I guess we want people specifically who would report bugs or information on libraries. We would want them to run with this flag, so we know immediately some of the configuration options here. Cool. So minus native image -info here to add this information. So now we have a new native image here, and this one is now the one that's configured for reflection, and I can here say foo, or I can say another method that was not available, and it now has picked up that reflection configuration.
Yes. Well done.
All right, cool. Thanks. And yes, so we are here. Yes, so config merge dir is the option to merge into an existing configuration, and before I was using the flag, a different flag. I was just config output dir for creating a new configuration. All right, cool. Okay, that's for the reflection configuration, because the reflection configuration and serialization configurations, this is one major part where native image is sometimes struggling because of this assumption we have to make that the world is not unlimited, and so we need to know where a reflection call could occur. And in general, it's not, in doubt, you would just add a class to reflection, because the downside is only that your image size gets bigger, but you're more likely to capture cases that your application would require.
Right, and I've been following OpenSlack for some time, and sometimes people ask why the jar file is bigger than the executable image if you say it's so tiny. And the reason why, because it includes already some runtime components, your application, and it's standalone. You can run it everywhere, right? You don't need the GVM. Just make sure that it's the same operating system. And the jar file is, okay, it includes dependencies, but it's not runnable. It's runnable if you have the GVM. So that's the difference. But you can compress native image as well. There is some this command line UPX tool, then you can compress it with, and it will get even smaller.
Right. Yes, we can hear the native image is relatively big still. It says here, I think, yes, so 13
megabytes.
13 megabytes. That's right. But we can use the UPX tool, which is a universal packager, and we can just here run it with -7 and -k for keep, and then we can run it here, and that actually compresses that executable automatically, and we get a new executable which is now only 4 megabytes, and that's now everything of your application, and that's much smaller than you could ever get with a jar file plus the JDK and the JVM, etc. For complex applications, this could then even be smaller than the jar file. So we have seen Spring native applications where compressing it with UPX actually makes it even smaller than the jar file. All right, cool. So now, but this reflection configuration is not the only source of potential issues when creating a native image out of an application. The second source of issues is often related to class initialization. And for this, I have a little bit of an example program here, a very small one, with two classes. I have a class A, and class A has a static constructor that says hello, and then class A also in the static constructor is creating an instance of class B. So when you run the static constructor of class A, class B will be initialized, and class B would then in its static constructor also say hello, so we know when it runs, and then we have the main method here. So
I suppose those classes will be initialized at build time when you try to build.
Yeah, but I think I think the default would be that it's at runtime. So let's just run the program first. So if you run the program, it will be here, static B initializer actually runs first, because this statement is above this statement. And then we get the static constructor of A, and then we get hello from world and hello from main. And if you would now create a native image from that, that would be exactly like, that's the same. Like if you do native image A here, it will just create an image that is doing the exact same thing, because by default the classes that are in the user space, they are initialized at runtime. It's just that like we have JDK classes and core library classes for some frameworks, they are marked to be initialized at build time to be more efficient, because you can cache things, and in general it's more efficient to initialize a class and its caches already at the build time, right? So here we can run the application, everything runs fine, everything's good, right? So now, but let's say we want to be more efficient with class A, and we want to have something that the cache of class A is initialized at build time, right? So now we need a flag. So that would be native image, and it's...
yeah, there is the ---- initialize.
Okay.
at build time.
At build time, okay. And then we need...
And then the class name.
We need the class name, okay. That would be A here. Okay, let's just say we initialize at build time A, and then A again. So we see actually now, so now the static constructor of A, so the code that is executed in the static constructor at A is running at the image generation process. In the image generation process at image generation time. This can already be a problem sometimes with some libraries where that would do a lot of things at build time, like starting new threads or other complex operations. It also means that any values that would be cached in static fields of class A would be taken from the time when the image was built. Like one relevant thing there often in practice is, for example, let's say a threading framework that selects the number of threads based on the number of cores of the processor. So that will be one of the cases where like it would take the number of processors from the computer on which you built the image, and then it would never update that again. So that can be sometimes also an issue for performance or other unexpected side effects of this build time initialization. And what we see here as well is that after hello from static constructor of A, we also have initialized now B at build time because of this dependency, because A, the execution of A would cause the execution of B, right? And now I think what we can, however, do sometimes, and this later gets us, I think, a build error, we can initialize class B at runtime.
Right. Yeah. So this option, you just substitute the word build with run in the same option.
Oh, okay. Okay, so it's initialized at the runtime. Okay.
Yeah.
Okay.
And the class.
And the class name, and then there's a couple tracing options as well, right?
Yes, that is minus trace minus class trace initialization. And also you can pass the exact class name, and you can trace the path to the package as well. So in this case, you will need to trace class A.
Right, class A, right? Or class B, I think you want to trace here. Oh, yeah, I think so. Because, right,
right.
yes.
The
class, yeah. So in this setup now, we have now told the image generator to initialize class A at build time, and we told the image generator to really initialize class B at runtime. And then the image generator would say, okay, I cannot do this because there's a dependency between class A and class B in terms of initialization. And this trace class initialization gives us this information on that, like, the class B was initialized because of the static constructor reference from class A. And in general, your user classes should typically be anyway initialized at runtime. So for a lot of regular user programs, none of this should matter. There could be just some special case libraries, frameworks, or GDK classes that, for performance reasons, were chosen to be initialized at build time, and then this caused some of these issues. And so there's a lot of other fun flags, I think, to look at this image generation and do a lot of reporting on it.
One of the most, I think, efficient and visually appealing is to print the tree of the classes that were initialized. Then you would see class called another class, and then down another class, and so on. So this will be a minus H colon plus, and then print analysis called G, all letters kept.
Okay.
Yeah.
Okay. All right, cool. Okay, and can you also print some? I think you can also print the object somehow.
Yeah, you can also.
So that would be. Let's just print the call tree for now, right? Okay. So this is now printing the call tree during the analysis, because during the analysis phase we are looking at which method calls which other method, and it now said it said it created this file, so I can already because you only want the analysis here, I can already kill the process. So now we have those reports, and we can look at the call tree. Okay, so cool. So we have here the call tree now as seen by the native image generator for our example program. So it will be here the VM entry points. It would be here. Okay, so we see that that we have an initialization of class A, which is the main class. So this is the first call here. That one is then calling the constructor method of P, and later on it's calling printstream println. That's calling printstream println, printstream new line, buffered writer fluff buffer, buffered writer, ensure open. That would then go to the writer, output stream writer. Later it goes to a stream encoder. It goes to stream encoder.impl-write, stream encoder impl-write, and then it would later call here to jarbuffer.put. And I think this is when we finally go to a native method that puts out a character on the console. Yeah. So this is how you can see the power of abstraction of the Java libraries from printstream.println down to now the actual character buffer.put. And the native image generator is always like analyzing this path to make sure that everything that is reachable from an application is included. And here you can also see, yeah, there's here some thread stuff, some SVM stuff, strings, files, a lot. Let's see. Okay, so this is a total here of my application on the, you see this here. I'm currently blocking this in the view. So here it's 62,000 different methods that were identified as potentially reachable in this native image. And this is the call tree. Mm-hmm.
Right, and also if you would like to look into the static analysis results, you can also use this flag -h colon plus print class initialization and pass it to the native image builder.
So print class initialization. This way?
Yes.
Okay.
It will also write the output as a text file.
Initialize the configuration. I think that's okay. That's already the output, right?
Yeah.
We can. Okay, good. So now we go again to our reports. We can go via initializer configuration. Okay, yeah. So now we see all the classes and we see the decision whether to initialize a class at build time or whether we initialize a class at runtime. Right, and we can see for many of the JDK methods we are, or for also most of the substrate VM itself, which of course is written in Java itself, like all those classes that are on the substrate VM runtime system, they are all initialized at build time because you want all of them to be ready at the point when you start the native image for the best startup. Mm-hmm. So this is here. What else we had? Oh, we have this dot file. What is in this dot file? Initializer dependencies dot.
It's a graph-based format for the graph, so you can take it and visualize and get an image out of this.
All right, I guess I will need the graphics for this.
I don't know if it will work. Like you can find an online graph-based things, but I'm not sure if they can handle. Like if your browser will handle this graph of this size easily.
Right, because it's probably pretty big. Okay, let's see. Okay, that outputs something, but I think we need to put this into an SVG file. Probably. It looks like an SVG file to me.
Let me Google that very quickly.
Yes. So this is output format. I think I need the output format too. We need Maybe PNG.
If anyone in the chat knows how to do the GraalVM thing, then
it said something about graph being so large or something. Okay.
I mean, you can try something like,
Yeah,
here's the link. Here's the link in the chat, right? There's a sketch-viz something where you can probably
Stack Overflow to the rescue. That sounds about right. That is initialize the dependencies, output file.ps.
Do you know what to do with a PS file? Are you gonna print it?
I think that should open, right? It's not opening. All right, let's see. Let's go to native image. This is the class init demo. And then this is the reports. Yes,
reports.
The PS
yes.
file. Yes, this should open. It's trying. Okay, maybe I'm too optimistic here. All right, maybe we need this. Oh yeah, we just need to pipe the output. So Dot would just pipe the output as a true Linux tool. It's just outputting on the command line, and maybe that's better. Okay, that's the output as a PNG file. Okay, I think
it was too large.
No, I know what the problem is. Right, yeah. At some point, like the graph goes in, like it's a sort of a tree, right?
Right.
Sort of a tree, but this tree is, I think, like hugely wide. Like it's it's so wide that it's like absolutely impossible to.
Yeah, I'm trying to.
Like PNG is not ready for the native image output files.
Right.
You need different format.
Yes, this is challenging. Open maybe it's another application. Maybe we open it in Google Chrome. Oh no. I think this is. Oh yeah, no, we're almost getting there. You can see it a little bit there, but
yeah, just no, just keep zooming.
Yeah, unfortunately, it doesn't.
The files.
There's like I think we should file a bug against Chrome. It's only 500% zoom possible. Open with image viewer.
You're not giving up.
Yes, no, I'm not giving up here. All right. I guess one would have to select the subset here, or have a better way to visualize this dependency graph. But yeah, in this dot file would be the dependency graph in dot format, so it can be visualized.
You can also visualize the objects that you mentioned before, and the option for that.
Yeah, we can later use the GraalVM dashboard, which should be better at visualizing some of this. Yes, we can see here also reports on the classes that were included in the image generation. We see here our classes A and B, which came from our own input, and then we see the classes from Substrate VM. We see here Java util, etc. And we see here also a couple classes from the GraalVM compiler. Also, the GraalVM compiler itself is not included in the image because the image is not dynamically compiling. It would only be included in the image if we add like JavaScript to the image or Python execution to the image. Alright, cool. I think we have one more example, right, Ola? We have the example. Yeah. Okay, I have it here on the IntelliJ somewhere, which is the multi-threading example here.
Yes, right. And this is just, it's not a big application, and what it does, it synchronously and asynchronously executes threads, and the logic is very simple. It starts a few threads, and every thread loops through exactly same array of integers and generates a stream of pseudo number. So, and then the program calculates the time to perform the task.
So it's just doing some calculation in parallel here.
Yes.
And
yes, but to make it more interesting, we also included two libraries. We will use the JSON and XML parser libraries. So these libraries are itself twice bigger than the program, maybe even more, and that will add to the overall size of the image. And this example I would like to show how to decrease the final executable image size.
Right.
And how to investigate this problem using the GraalVM dashboard tool. And GraalVM dashboard tool, it's a relatively new tool. We just released it last year, and it's a beta version. So you can probably show it to the users now, and it's hosted on graalvm.org. So this is
right. I think I need to okay. So I need to first get my I need to go to the multi-threading
demo. Let's try it oversized.
Right. Let's
oversized. But
yeah, oversized. Yes. Okay. And now we need to MVM package, I guess.
Right, and at
this step, here we have the native image plugin, right?
Exactly. So yeah, if you could open the POM.xml and show how we actually instructed Maven to build a native image at the same step. So you see we have the Maven plugin included, and then if you look into
right. So here is the Maven plugin with the GraalVM version. And then we have here configuration with a couple configuration flags, actually.
Right, and the first flag, well, no fallback image, it's already clear what's that. And then the second one, it tells to dump the diagnostic data to the dump file. So that's the path to the file and the name. And then the next option, -h column plus dashboard all, tells to export dump data in all formats. And there are 3 formats this dashboard tool supports. So depending on the size of the application, if the application is big, of course, then you would better dump data in chunks, depending on the type you need to review. And let's look into the configuration and diagnostic data this option can output.
Right, we have this, yeah. So I can now, but now I can do, yes, actually do the output. Oh, that's cool.
Right.
Because I was to ambient, so that's what this native image plugin does, right? If I do NVM package, it has the execution goals package, and then in packaging, it will already create the native image.
Right.
Cool. And we have now a file, which is this file on target dump file oversized. Okay.
Yeah, and by default, this option will output the file in BGV format, and that's the format that GraalVM dashboard only supports for now. But there is also a possibility to dump file in JSON or JSON printing format as well.
Right, and here we have 37 megabytes on this file. Okay, cool.
Because this file is hard-coding as a compiled code, like it indexes the data in its own way, and that's why it weights more, than a jar file or an image file.
Right. We can see here again, yes, so the image here for this multi-string demo is 18 megabytes. But again, if we want, we can do UPX -7 -k.
Yeah.
And then we can make that even much smaller if you want.
Right.
So that would be again smaller, and I would have now only 6 megabytes for my image. Okay, and now we need to go online to the dashboard.
Right. So you go to graalvm.org.
Okay. GraalVM dashboard. All right. Cool. And now we
right, and you select the file, the dump file.
I need to go to here, and then I need to go to demos.
GraalVM demos, probably. That's the
right. Native image, yes. GraalVM demos. That's right. Now we need to go multi-threading demo, and that's the
oversized and target.
In target, we have here this file, which is the BGV file,
right? And as you can see, the user interface is quite straightforward. There is not much to learn, and it's explicit how to use it. So you just have the code size breakdown window and heap size breakdown. So what code size breakdown window shows you? It shows you the size of the packages included into the native image proportionally to the size of the application. So here, if you go, you can go deeper and deeper into each package and down to
right. We can look into this.
methods.
Maybe look into this faster XML. That's faster XML checksum, and then we can look here. Data bind seems to be the main package, and then we have here various forms of data bind that would end up in the image, and you can always see the size of the bytecodes that were included in the image from this package. So this way we can really look at like what is worth like optimizing for when trying to strip down my application. Yes,
and like if you go back, if you reset, if you press reset, then you will get to the initial division, initial view. And for example, you also can notice there is a call to java.net library. Which is
here we have java.net, yes.
Yes, and that might be because there is the method in the application get resources, and this method probably is calling some URI, and that's why. And this also, it's also called by the package, by the parser package. So we can try to optimize the program, for example, and let's see, you will see that this package could be omitted, and you will see how the overall size of the image will be
smaller.
Shrunk. Yes.
Okay, should we modify it here in place? How to
just change to the other directory, to the other folder of the project. It will be multi-threading demo improved.
Okay. So we go here, we open the second version. To new window.
Right, here we will use.
Okay. So this is the different version where we don't use, we still use the XML library, right? But we don't use some of this logging here, right?
Yeah, and what we did, we also moved the configuration initialization to the static block.
Oh, that's why. Yes, we changed that the configuration is actually loaded now, no longer in the main, but it's loaded in that static block, which now makes it much easier. Like, which means that at runtime we don't need
these libraries to load
these XML libraries anymore, because they're only referenced in that static call. Okay, cool. So now I go to multi-threading improved, right?
Yeah.
Yes.
And you will also notice in the POM XML that there is this option, initialize at build time, which means initialize as much as possible at the build time. They're not explicitly telling to initialize some specific class. Yeah.
Right. This is actually initializing everything at build time, right?
Yes, right.
Yeah. We would typically recommend to do this only for specific classes where you know it will give you an advantage, right? And a class that could do a lot of work in the static constructor that would be then loaded automatically, and then you don't need to pass the config. So the config is then already baked into the image. Okay, so you have the new image here running, and now we can compare the size. The size is now here. Yeah, the size has gone down to only 9 megabytes, whereas before it was here on 18 megabytes. So we have here moved the application down by 2x, and we can do the same UPX trick if you want to go even further down with -7 -k target, and now we ask multi-threading image improved to go down, and that has packed the file. So now the oversized target versus the improved target is here the improved version can now go with 3 megabytes. So I have here a full Java application, everything included, as 3 megabyte, and an application that uses an XML parser and lots of other things. So this just demonstrated that you can also for Java application go to a very small packaging size, very concise, and now we can have a very small Docker image from this type of application.
Yeah, and if you return to the dashboard,
Yes.
there is another cool visualization, this heap size breakdown.
Right,
Which
and I think we want to open the other version, right? Now let's open the other version, which is the demo improved. And now here again in target, right? Here is the dump file improved, open.
Yeah.
Okay. Now I have the second file open here, and that's the code size breakdown new. Oh, and we can now see that in this new code size breakdown, this faster XML and other things here, they're just no longer there. And therefore the total code size is much smaller than before. And you said we also have the heap size breakdown, right?
Right. And this view shows you what pre-initialized objects occupied the heap. So, and you can also you can track the sequence of call to some methods with this tool. And there is another view available with this tool called Points to Explorer, but you can get to this window, to this view from code size breakdown, because you have to have some entry points, go into Points to Explorer window. So go to the code size breakdown now,
okay.
Choose some class.
Okay, let's go Java util. Let's go Java
Whatever.
util. Maybe we go
Find some application.
linked hash iterator. Okay, that's my iterator, my hash map iterator. Okay. I think it should be down.
Go down to the method.
I need to get a real method. Okay.
Yes.
Okay.
And then if you would like to investigate the method even more, like deeper, then you...
Oh, now I have, now I'm down to the method. Okay.
And so
yes.
it expands the graph recursively until reaching the entry point of the method.
Yes.
And
yes, also here we still have the same issue that the GraalVM has in terms of, because the graph is here obviously very big. I think I selected a method in the util that is called from everywhere. So I think that can that can be here part of why it will be hard to navigate around here. But yeah, we are like we are trying to make this tool. Oh, here, yeah, we can move here. We see here the method weak hash map, right? Yes. And so what does it mean, one edge here, Ola? What does it mean? It means that here I see, can I zoom here? Yeah, I can.
Right, yeah,
I can.
So you see the calls to the method and why this method was called. And there is one other cool thing, that if you have visual extension opened, like if you have your example opened in visual extension, VS Code, then yes, and if you install this special plugin called Points to Source Line, this is an extension for VS Code, then you can even, by pressing on the exact method, go to the source line of the application in VS Code. So this is a new cool feature.
Cool. Yes, we will. Yeah, but I guess we'll reserve that feature for another stream session to demo it in more detail, and also as we improve this tool further. But yeah, if you do a lot of work with native image, please try out this tool and give us some feedback as to what you would like to see there, and how we can improve this tool that will allow you to explore then also in a visual way the call graph. All right, cool. Do we have any questions in the Twitch chat or from you, Oleg, maybe? Yeah, now in 4 minutes we will have Sebastian. Deleuze on, and then we will continue here with specifically looking at the Spring framework and Spring Native, and how to compile Spring Native with GraalVM into native executable.
We had a very lively discussion in chat about various topics.
Hopefully positive. Everything's positive still.
Oh, everyone is absolutely ravishing about how excellent this stream is. No. There are actual questions about the UPX and how to build cross compilation, like for the native images and so on. So shout out to G Linboy for good questions. I enjoyed that little chat we had.
Excellent.
And they are saying that they're a Java developer and using Spring Boot. So Jillian Boy, like, you are here for a treat, because Sebastian should be joining us like any minute now.
Yes, that's right. And you're here for a treat also with respect to UPX, because UPX is specifically interesting for Spring apps. We will use UPX in the follow-up stream here in the next hour to use it on a large Spring Boot application. And we will demonstrate how it can this way get like smaller than even the Java. But yeah, there's some trade-offs with UPX, and we will discuss that as well in more detail in the Spring session. All right, cool. Excellent. Well, thank you, Olha, for joining me here.